Okay, number 2, composition of functions. We are going to go through both with the calculator and without the calculator, and you can decide which method works for you for part of the problems anyways. Okay, so what you should be able to do, and really without a calculator, is find an explicit equation of a composition, and that could be either f of g of x or g of f of x. Just pay attention to the order listed. So to find the equation, because again, that composition is its own separate function, we are going to pay attention to how that's written. We're going to start from the inside out and just do some substitutions. So we're going to first take out g of x and place it with what g of x is equal to. So this will look like f of, take out g of x, put 8 minus x in its place. And then we will substitute into f. Everywhere we see an x, that's going to come out, and 8 minus x will go in its place. So instead of 0.5x, we'll have 0.5 times 8 minus x. Everything else stays the same. And then we'll just simplify that. Let me distribute that through and combine like terms. So the equation for f of g of x looks like this, which would just be a straight line, slope of -1/2, y-intercept of 5.5. That's a little bit hard to get out of the calculator, in this one in particular, because you're going to see just this little teeny tiny piece of a line. Okay, let's get that in the calculator, and then we can do the domain part C both with the calculator and then also by hand. So let's go ahead, and this is a little bit tricky getting this in there just right. So we're going to put y1 in there. That's 0.5x plus 1.5. And then to get the restricted domain in there, we need to divide by parentheses. We've got to set that inequality apart and say x is greater than or equal to 1. All of these symbols are under test, which is second math. So greater than or equal to 1, and second math again, but go over to logic, x is less than or equal to 5. That's what we need to type in there so that the calculator, oops, that's not at all what I meant to press, so that the calculator understands what we're saying. Okay, we cannot just put 1 is less than or equal to x, which is less than or equal to 5. And then we put y2 in. Go ahead and try that. You can look at mine when you're ready. Oops. Oh, sorry about that. Okay, so 8 minus x divided by parentheses, x is greater than or equal to 2, and x is less than or equal to 4. Now, the nice thing about this method is because you've already restricted the domains, if we put the composition in there in a smart way, it will restrict its domain for us automatically. Instead of writing f of g of x or typing f of g of x, we just have to think about what are these functions called in the calculator right now. F is called y1, so I'm going to go to alpha trace and just select y1 of y2. That's like saying f of g and then of x. Yes, the calculator knows that those parentheses mean substitution and not multiplication. And now if we look at the graph, we've got f, we've got g, and then this little tiny black segment there, that is the composition f of g of x. Now, to find its domain, we've got a couple options. Option 1, depending on how your graph looks, you might be able to just look at that and say, oh, I only see that little black graph for values between 3 and 4. Great, find it that way. Or, maybe better yet, although you have to be careful how you're reading this, y3, if I went to the table, by the way, so second graph, go to the table, only has y values here, right, at 4 and 3.5. There's errors everywhere else. But we do not care what those y values are. We care where they are in terms of which x values do they belong with. So those line up with, let's see if I can do this right on here real quick. Okay, here we go. Let me look at this here. So we don't necessarily care that the y values are 4 and 3.5. We care that they line up with these x values. This is the domain. This would give you the range if they asked the domain. So the domain is x between 3 and 4. And again, that's sort of the calculator method. Now, if you're going to do that by hand, we have to think really carefully about how this is set up. f of g of x. And we're thinking about the definition of domain. What x values are we allowed to plug in? Now we're putting g into f. So step one, we need to put g in f's domain. We only plug it in if it fits in its domain. So let's test what that looks like. So we're going to take g of x and squish it between f's domain, which is 1 to 5. But let's take out the term there, g of x, and actually replace it with what it's equal to. And then we're solving for x. So I'm going to subtract 8 from all 3 parts of that inequality. That puts me here. Okay, subtracting 8. And then I'm going to divide by -1. But if you remember, there's this goofy little rule that says, oh, when you divide an inequality by a negative, you have to flip the sign around, that inequality sign. And just because we typically write the smaller number first, we're going to pivot that entire thing around, switch those signs back to less than or equal to's. Now, this is not the final answer, because what we have not done yet is consider g's domain. So step one, I thought about f's domain. Step two, now we need to intersect this one I just circled here with g's domain. Down here, so I have some room. So I'm going to take 3 to 7. I'm going to intersect that with g's domain of 2 to 4. And we're just looking for what numbers did those two inequalities have in common. Where would they overlap? You could draw them on a number line. That helps to actually see where they overlap. But what they would share are values between 3 and 4, which again, we saw in the calculator, but that's the final answer. That is the domain of f of g of x.